this, and then if we have some time, maybe some angle relationships.
Okay, what was the first thing you said?
I wanted to work on the page that you have up here,
Okay.
and then if we have time, maybe some angle relationships.
Okay.
Okay.
So, the area of a trapezoid. What's the formula? This is actually a formula that's worth knowing.
Isn't it like B1 plus B2?
Mm-hmm. What you're looking for really is the average base. So what would I have to do to B1 plus B2?
Multiply? Or
By 2.
I'm sorry?
Divide by 2.
Okay.
And that's one way to remember it.
Mm-hmm.
Is that a trapezoid, a rectangle is base times height. But a trapezoid has 2 different bases. But what you're really looking for is the average base, which is 1/2 of B1 plus B2.
Okay.
That's the average base. So that's the way I remember it. Okay. Now, what's B1?
25.
What's B2?
13.
And what is H?
Well, don't we have to solve that or whatever?
You have to solve that triangle. But
Okay.
it's a recognizable one. It's a triangle that you really don't have to use the Pythagorean theorem on if you recognize it. There's a few triangles you should learn to recognize. One is a 3, 4, 5 right triangle.
Okay.
That's what this is. It's a multiple of a 3, 4, 5. It's not a 3, 4, 5. It's a 6, 8, 10.
Okay.
Which makes H6. In other words, I didn't have to go through the Pythagorean theorem because I recognized that that was the 5 and that was the 4, so that had to be the 3.
Yes.
Okay.
All right.
So 6 is the height. Now if we do this math, we get 38 divided by 2, which is 19 times 6.
Then I got 189.
19 times 6 is not 189.
Hold on. Let me do it again.
Let's see. 25 plus 13 is 38. 38 divided by 2 is 19 times 6.
Okay.
Only reason I know it's not what you told me is because the last digit has to be a 4.
Yeah, I got 114.
Yeah.
Okay.
In other words, you can always kind of semi-check your answers knowing what that singles digit for the answer has to be is 4. In other words, 6 times 9 is 54. So that last digit can only be 4. Okay? Now, what kind of triangle is this? They want the area of this triangle also. So we need to figure out what H is.
Okay.
What's the area for a triangle, first of all?
It's...
Don't look that up.
I'm not.
When you turn pages, when I ask you that, that's not a good thing. If there's any formula you want to memorize so that you don't have to look it up, it's the area of a triangle.
Oh, 180. Well, it equals 180.
Equals 1/2 base times height.
That's right. Okay.
Okay? That's not 180.
Okay.
Because you multiplied base times hypotenuse. That's not the hypotenuse. That is the height. That's what I'm calling H right there. Okay? So we have to figure out h. Most geometry problems are all this way. There's very few geometry problems where you solve them in one step. You have to solve something else first. Just like on this trapezoid, we had to solve for that before we could go further. Well, we have to do the same thing here. Recognize this triangle.
Okay.
Do you?
Is it a 3, 4, 5?
It is. Which
Okay.
h what?
It would be
a multiple of it is
3, so it'd be 9.
Okay, cool. So the area is 1/2 the base times the height. That is 6, and that is 54. Okay. Now, if you're not looking at they're not always going to give you just 3, 4, 5 triangles. Sometimes they're going to give you triangles that are not 3, 4, 5, and you have to use the Pythagorean theorem to solve for that side.
Okay.
But we'll worry about that when we get there.
Okay.
Because I'm not sure how much of that you actually are going to have to do.
Yeah.
So I don't want to spend what limited time we have giving you shortcuts onto how to do that. Okay, so let's look at this one.
Okay.
Well, first of all, I need to ask some questions. I assume that this 4 is this measurement? Because I can't really tell.
Yeah, I believe so.
Okay. So they're saying the area of the shaded triangle is 12. Well, what does that make this distance right here? It's a right
3.
triangle. In other words, the area is 1/2 the base times the height. They told us the area was 12. We can see that the height is 4. So what is the base? The one that I've circled there.
So would I just do 12?
Solve that equation.
Okay. So I would just do 12 then minus the 4.
Not minus. That 4 is a multiplier.
Okay, so divide it by 4.
Correct.
And then divide it by 1/2.
Easier way. Well, no, the easier way is to combine the 4 and the 1/2 first. What's 4 times 1/2?
2.
Okay, so let's just replace that with a 2.
Okay, so 12.
Now you just divide 12 by 2. Makes it much simpler.
So B equals 6.
Okay. So if B equals 6 and x minus 3 is what's equal to B, in other words, x minus 3 equals 6, what's x equal?
3.
Solve that equation.
Okay. 9.
Okay. So now, do we have everything? Let's see. Let's label some stuff here. So this is 6. That distance. And that 2, I presume, is that little distance there?
Yeah.
Okay. So now that we've figured out x, all right. If we wanted to figure out the area that I am drawing, just that for the moment.
Okay.
How would I do it?
Would you just take like the base and the height of the rectangle and then subtract out
Perfect.
yeah.
Exactly. So what's the length of this base? If x is 9.
Okay, so hold on.
So that's 9. That's
23,
8,
I think.
and that's 6. So
So 23.
23 is this length right there.
Okay.
Okay, and what is this length? So far, we're just dealing with that.
Oh, because we have the 4 and the 2, so wouldn't it just be 6?
Uh-huh.
Okay.
So, you were correct that the area of the white that I have surrounded in red, we'll call that the area of the white, is equal to the area of that top rectangle minus the area of the triangle. What's the area of the top rectangle?
2 times 6.
No,
12.
no, not that. I meant the outside rectangle.
Oh, 138.
Outlined in not red, this one here. In other words, that
Okay,
big
so
triangle. What is that?
138 minus the 12.
It's just 6 times 23.
Yeah, so that's 138.
138 minus the area of the triangle. So that area is 126. Now we have to add to that area, because we couldn't start with that area to begin with. I guess we actually could have. It's just as easy to look at it as two different problems. That area is pretty easily to figure out.
Yeah, 23.
Right, so I just add 23, and I get 149 is the area of rectangle ABCD. Assuming, and I can only assume this, that the area they're referring to is that. That's 149. Now, if they're, no, because that was the area of the white only. If we're really, I'm not sure what if they're really asking about that rectangle, then we have to add 12 back to this.
Okay.
Because it's 161. In other words, it is, this was 23 and that was 7, correct?
6.
6
Yeah, plus 1, which is 7. Yeah, sorry.
So the area of that rectangle is 7 times 23, 161. I made it to be a little bit harder than it was.
Okay.
In other words, is all you really need to do to figure out the area of that rectangle is to figure out that that's 23. In other words, I did have to solve for x. Definitely had to do that. But once I solved for x, then I knew the base was 23 and the height was 7. I could just go directly to that times that.
Yeah. Okay.
A little bit confusing because you're not sure if they're talking about the area of the rectangle or the area of the white area.
Yeah. Okay, and I didn't send you a worksheet for angle relationships. Oh, wait, we saw that one. Never mind. Sorry.
It's okay.
Okay.
Shall we do this one?
Yes, that'd be perfect.
Now, let's look at this. Usually these problems like this, you kind of have to divide up
Yeah.
into shapes that you have formulas for. Well, I don't have a formula for that shape unless I wanted to figure out the area of that square, perhaps, and then subtract the area of that triangle. So I could do that. So it could be the area of rectangle 1, which we know, plus the area of triangle 2, which we know, plus the area of this square number 3 minus this triangle number 4.
Okay.
Now, whether we know all of that or not, I don't know. Let's see if we can figure it out. First of all, what is this dimension? Let's talk triangle 2.
Okay.
The base.
The base.
Yeah, what is this measurement right here?
Should we use like the Pythagorean theorem?
You could, but like I said, learn to recognize a 3, 4, 5 triangle.
Yes, it's the, okay. So it would be 8.
Okay. So we know everything to know about triangle 2. We know everything to know about triangle or rectangle 1. Plus, because this double hash mark, that means that is 9. Which makes that what? This measurement right here.
9 minus the, oh wait, sorry.
That's 6 right there.
Okay. So then it would just be 8 minus, so 2?
It's 9 minus 6.
Oh, sorry.
In other words, this double hash mark right there and this double hash mark means the length of those two lines are the same. That one is 9, this one has to be 9. And if that's 6, this has to be 3.
Okay.
If that's 3, what is the base of this triangle that I've put a dotted outline around?
5.
Okay. And what's the height of that triangle?
3.
Okay. Now, the one problem with the 3, 4, 5 triangle is it's frequently easy to misread a triangle. That hypotenuse is not 4. When you have a 3, 4, 5 triangle, the hypotenuse has to be 5. Well, this is a 3, 5 something triangle. So we have to figure that out. And once we figure out that hypotenuse of that triangle, we have all the measurements we need.
Okay.
Let's do that first. What is this measurement here of this diagonal line? It's the square root of something. What's the square root of? Whenever you solve right triangles, the answer is always the square root of something.
Okay. I'm not sure how to do that.
Well, it's the square root of the sum of the squares, 25 plus 9. So it's the square root of 34. However, the more I look at that, the less we need to know that. In fact, let's erase that because we don't need to know it.
Okay.
Didn't realize it when I first looked at it. Okay, so what do we have? We have, let's start with the area, okay? So the area of the figure equals the area of rectangle 1 plus the area of triangle 2 plus the area of rectangle 3 minus the area of triangle 4. We'll call that 4 right there.
Okay.
And that is not a square because it's 8 by 9. So it's a rectangle. Okay. Now, I believe we can fill in all of those.
Mm-hmm.
What's a sub 1?
54.
What is a sub 2?
Uh,
The area of that triangle.
is 24.
What is a sub 3? The area of this.
Okay. 72.
Okay, and then finally we're subtracting out the part right there. What's that?
It is 7.5.
Sure, they had to throw in a decimal to mess us up. Okay, figure out what that is. Let's see, that's 78. So that's 150 minus 7.5, 142.5. That's the area of the shape. And there's a couple ways I could have done this. It didn't necessarily have to do it the way I did it. In other words, I didn't have to draw that triangle. I could have actually broken this up into a second rectangle. Then I would have had a trapezoid there. And I could have figured out the area of the trapezoid as long as I knew the area of this. Well, that's 9, that's 6. As long as I knew this distance here, then I could have done it that way. So these problems, there's always multiple ways of doing it.
Okay.
If I can deal, the formula I generally use is if I can deal with nothing but rectangles and triangles, I'll do it. And notice that's what I did. That was a rectangle, that was a triangle, that was a rectangle, and that was a triangle. I didn't have to deal with a trapezoid.
Mm-hmm.
So
Okay.
I didn't have to bring in that more complicated formula. However, I did have to deal with the concept of subtraction. In other words, this area right here is the area of that full rectangle minus this little triangle, right?
Mm-hmm.
That's what I did. And it made everything rectangles or triangles, which I like. I don't have to go to trapezoids.
Okay.
All right, let's see. Did you say you sent me something else?
No. Well, so we could either work on maybe like angle relationships or
Yeah, I'm not
like,
quite sure what you mean by that. Tell me what you mean by that. Can you give me a problem?
yeah, here, I could see if I have something on my phone or something else that may be helpful is like formulas and stuff, because I've been like, we can have like a cheat sheet, like we're allowed to have like, like a paper to help us with.
Perhaps you mean angle relationships to mean this. Which is the smallest angle of that triangle?
What's the smallest?
Uh-huh.
The top one? Or no, sorry.
Nope. It's always opposite the smallest side.
Oh, okay, C.
Okay. And the biggest angle is always opposite the biggest side.
Okay.
Which makes A the middle angle. So C is less than A is less than B. Is that what you meant by angle relationships?
Yeah.
Oh.
And like, yeah, pretty much. And like solving, like.
There's one other thing quite important in triangles.
Okay.
And you kind of have to memorize this. Any side of a triangle has to be less than the sum of other two and greater than the difference of the other two. So the only part, I love these things where you don't have to memorize the whole thing. In other words, if you memorize that along with its reverse, well, this is the reverse. You don't have to memorize that. You just know that any side's less than the sum of the other two and greater than the difference. Okay, so let me give you some sides of a triangle. 3, 3, 5. And if this is not true, then these triangles can't exist. Is this a possible triangle? And you have to check every side. So check that side. Does that satisfy both conditions?
Yes.
Does this side?
Yes.
Does this side?
No.
Got to be greater than the difference. It's less than 6, so it's less than the sum, and it's greater than 0. So that's a legitimate triangle. I can draw that triangle.
Okay.
However, if all of a sudden I said to you, well, how about a 3, 3, 6 triangle? Is that possible?
No.
No, it isn't, because, and there's no room for error there. In other words, 6 is not less than 3 plus 3. It's equal to it. So there's no way to draw that triangle. And one way to kind of remember this is the shortest distance between 2 points is a straight line. So x is the shortest distance between that point and that point. Okay? That means y plus z has to be greater. If the shortest distance is x, then this is going the long way, right? In other words, going to there and then there has to be greater than x, which means x has to be less than y plus z. And that's what the first statement of that theorem says, is that and all three sides have to satisfy it. But the main thing to memorize is that any side is less than the sum of the other two.
Okay. And then, so for my important triangles, real quick, it's just 3, 4, and 5, and then 10, 8, and 6.
Well, it's 3, 4, and 5, and any multiples of 3, 4, and 5. It's not just 10, 8, and 6. It's 30, 40, 50. In other words, there's your basic 3, 4, 5 triangle. That's the smallest perfect Pythagorean triangle. In other words, there is no 1, 2, 3 or 2, 3, 4. 3, 4, 5 is the smallest. But any one that has that same shape could be a multiple of it. It could be 30, 40, 50. You want to recognize it. In other words, if I said I got a triangle that's a right triangle and it's 30, 40, you should immediately know that's 50.
Okay.
Okay? The other one that I didn't see anywhere, but the next perfect Pythagorean is the 5, 12, 13. You might run into that.
Okay.
Okay? Or multiples. In other words, it could be 10, 24, 26. That is one of those triangles also.
Okay.
Okay? But the two really most important triangles are not the 3, 4, 5, even though you'll run into that 100 times over the next 3 years. The two most important triangles are your 30, 60 and your 45, 45. These are what we call special triangles because they come up over and over and over. And a lot of times, the way to solve one, now I put what I call my unit dimensions on these. And what that means is the side opposite the smallest angle is always 1. That's square root of 3. That's 2. That's 1. That's 1. That's square root of 2. What you want to do is memorize the dimensions.
Okay.
The reason is what if I give you a triangle and I say it's a 30-60 triangle and that side is 3. Give me the other two sides.
Okay. The bottom one would be square root of, is that correct? Square root of.
Here's the thing you need to do, Hannah.
Okay.
When you see a second triangle and you recognize it, oh, that's this triangle up here, it's just bigger.
Okay.
First thing you want to do is what is the scale factor? Meaning, what's the factor between corresponding sides?
Okay.
What is it?
Would it just be like 4 then?
3 to 1. That's opposite the 30-degree angle, and it's 3. Well, that was opposite the 30-degree angle, and it's 1. Okay. So this triangle over here, every side on it is going to be 3 times whatever this is. So what the bottom side and the hypotenuse are.
So it would be square root of 9 and then 6.
No. Oh. 3 root 3, which is not the square root of 9.
Okay.
6 is correct. Because all you do is you take your scale factor and you multiply it by whatever these sides are. Okay. When I multiply 3 times root 3, I get 3 times root 3. I don't multiply it inside. I multiply it outside. Okay? Mm-hmm. And these two triangles are so important because as many times as you'll run into a 3, 4, 5 triangle, you'll run into these 5 times as many times. And you're always being asked to solve the other two sides of one of these special triangles. Okay? In other words, let's make this side 5. Now what are the other two sides? All right, better yet, hold on. Let's make this side 8. So that's all you know, is that you have a 30-60 right triangle and the hypotenuse is 8. You should be able to figure out the other two sides from that right there.
Okay, so one side would be 4.
Okay, so what's the side opposite the 30?
Opposite the 30, wouldn't that be 4?
And what's the side opposite the 60 degree?
The 2.6.
Don't give it as a decimal ever, unless the teacher specifically asks for it. The most exact answer is the square root answer.
Okay.
So what's the scale factor?
4 over 1.
Okay. So we have to multiply that by the scale factor to get this other bottom side.
Multiply the 3 by 4 over 1?
Uh-huh.
Okay.
What do you get?
12.
No.
Over 1?
Again, you're putting the 4 inside the radical sign. It doesn't go inside the radical sign. What I'm doing is I'm multiplying square root of 3 by 4. That's your answer.
Okay.
Okay? So don't put the 4 inside the radical sign and end up with square root of 12. That's not the way you multiply. When you multiply a number by a radical number, you just leave it outside. It's 4 times root 3.
Oh.
That's your answer. In other words, if I gave you a 30-60 triangle and I told you the hypotenuse was 8, solve the other two sides, this is kind of the way you want to do it. You want to do it based on this unit special triangle. And then always figure out the scale factor, big to little, and then always multiply the scale factor by these numbers to get your answer.
Okay.
Okay? Hannah?
Good.
Your test?
Thank you.
I probably will talk to you next year. Have a good Merry
Yes.
Christmas and a Happy New Year, and
You too.
I'll let your mom schedule appointments as needed for you.
Okay. Thank you so much.
All right, Hannah. Bye-bye.
Bye.